Hi folks, I hope that you are doing very well. So this is final exam review for 3033 Meteorology Hyflex Tulsa Campus course that we designed this one for the first time. So we are almost there. We have 2 or 3 days to our finals. So I just decided to make another exam review for you. So this exam will be consisting 220 points and it would be 66 questions. Most of the questions are multiple choice and some other questions that are matching, and you know that 150 points from 220 points would be from chapter 16 to chapter 20, and those chapters are actually more reading extensive materials, so you have to read through all this chapter before you sit for the exam. And another 70 points that will be comprehensive. That means questions from the previous chapter will be there. So let's begin our review. So in previously, make sure that you are familiar with the different types of heat: specific heat, latent heat, and sensible heat. So make sure that you can differentiate each of the heat. So what is a specific heat, latent heat, and sensible heat means? That would be the one questions in technical question is there, so that will help. There are 5 to 6 questions that I put from climate classification. So make sure that you know that early Greek classification was actually divided the climate classification into 3 parts: the torrid, temperate, and frigid region. And then the most important climate classification came is Köppen climate classification. So Köppen climate classification has advantages and disadvantages. So make sure that you understand that. And the advantages is that it's easy to measure. Disadvantages that other types of atmospheric variable did not have the consideration in here. But what is the basis? The base on the regional temperature and precipitation is the main basis for Köppen climate classification. So Köppen climate classification is mainly 5 types, but each for the highland. So make sure that each of the classification that you know at least the basic things. Like A is tropical humid region, so you have AM, AF, and AW. So AF means tropical rainforest, AM means tropical monsoon, and AF means tropical savanna. So make sure that you have understanding for each classification: A, B, and C climate. If you look further, like the A climate is divided into 3 parts: tropical rainforest, tropical monsoon, and tropical savanna. So tropical rainforest means AF, tropical monsoon AM, tropical savanna AF. So you have B, steppe, desert; C, Mediterranean, humid, marine west coast. So see, those are the main classification you need to know. And B climate, also see the D climate, this mesothermal climate. We don't have mesothermal climate in the southern hemisphere, so if the technical questions comes this way, you need to answer this question. And if you see that the ocean current, actually we have cold ocean current in the west coast and warm ocean current in the east coast. So this is one of the reason that we have a stable atmosphere, unstable atmosphere. You see the cold water stabilize atmosphere overhead. That's west coast. That's why we go to the west coast for a sunny and very good weather. Warm water destabilize atmosphere above. So west coast, pleasant weather and abundant sunshine, and west coast does have little precipitation. So make sure that you know all these basic things about the ocean current and also associated with the atmosphere. Then see that there are some questions from emission, that's carbon dioxide. We see that carbon dioxide, there is a kneeling curve that's established somewhere in mid-century. So make sure that fossil fuel burning, cement production, land use changes, all are the anthropogenic emission that are producing a lot of carbon dioxide adding to the atmosphere. And if you look at that kneeling curve has a intra-seasonal fluctuation. That's mean those fluctuation is happening uh, in the year. So make sure that why is that happening, because in the winter we in the northern hemisphere we all the leaves and everything that is going down, and in the in the spring that's all leaves are being blowing, so that's why the carbon dioxide concentration are differing from one to another. So make sure that you know all these things. That long-term carbon cycle, see the dead organisms sink into the sea bottom, the debris build up and it's compressed into the rock, sedimentation and limestone, all are the symbol that represent long-term carbon cycle. So long-term carbon cycles, it takes millions of years to recycle or to come back to the original state. And we have short-term carbon cycle, that photosynthesis, carbon dioxide converted into the energy, and plant death, recycle carbon back to the carbon dioxide. See soil, carbohydrate combined with carbon dioxide to make the methane. Ocean also absorb carbon dioxide, and when ocean water actually warm, carbon dioxide release into the atmosphere, so atmosphere get more carbon dioxide when ocean is warming. Also it is related to the pH, that means ocean is getting towards the acidic situation, although overall oceanic situation did not change much, but some places ocean actually becoming acidic, so that's why coral reef are actually dying or bleaching. So all these things, and you see that some of the terminology that you need to know: reflection, absorption and transmission, black body, perfect emitter, and absorber of energy, because black body does not reflect any sunlight. And you also need to know the spectrum, like when the white color actually divided into different spectrum, violet, red. So you need to know all this, why this is happening, because the color has a longer wavelength, it has a shorter dispersion. When you have the very small wavelength, you have it's penetrated in different way. That's why the red and blue are different when sunset happens. So there are some questions from there. Make sure that you know this. Make sure that you know the term greenhouse effect, how greenhouse effect actually affect on our atmosphere, and how the planet is being warm because of the greenhouse effect. So greenhouse effect is not a curse, it's a blessing in one way, but too much is everything wrong. So that's why when you have a lot of greenhouse gases into the atmosphere, that's mean it taps more heat, and that more heat lead more warming, and more warming lead different types of problems. So make sure that you know that all the greenhouse gas names, and how the greenhouse actually works, and how it is helpful and how is it detrimental when it's become more affluent. From the previous chapters, radiation balance, so make sure that the angle, tiltation, and all these things are depending on the latitude, and that's why the atmosphere is being absorbing more or less energy due to those types of situation. And also you know that those types of situation makes many places in terms of the latitude, the temperature differences. Make sure to understand climate change feedback mechanism. There are some negative feedbacks, there is a positive feedbacks. So in the quiz reading quiz you have answered many of the questions, so make sure that you know all these snow albedo feedbacks and what is runway greenhouse effect or something. So which one is positive, which one is negative, you have to understand that. There are some questions on that. So one of the example of the negative feedback is removal of atmospheric carbon dioxide. So from the atmosphere, it is actually depositing into the ocean water, and then ocean water depositing as a silicate rock. So this is how chemical weathering actually takes place to make a negative feedback. And silicate mineral absorb carbon dioxide with the presence of water. So make sure that you know that. There might be a question on that. One of the most important theory, that's Milankovitch theory, that's actually tell us the natural climate change with the axial precession, which we call UBOL, and change in eccentricity, change in obliquity. So all these things that actually works. So circle elliptical actually change every 100,000 years. So make sure that Milankovitch theory, that's natural climate change, is one of the accepted climate change, natural climate change scenario. So make sure that you know all these three things. So climate change atmospheric particle, how does that work? You see, sulfate aerosol actually work when volcanic eruption happens. Sulfate aerosol, a huge amount of sulfate aerosol injected into the atmosphere, and that actually block the sunlight, and this blocking is actually negatively affect. And in 1991 there's the Pinatubo eruptions, and these eruptions actually lower down 0.5 degrees centigrade global temperature for 2 years. So those types of atmospheric particles actually work as a to reduce the global warming or global temperature sometimes. So it's a negative and that's called radiative forcing. Negative radiative forcing. There is some positive radiative forcing. The carbon dioxide, methane, all greenhouse gases are positive radiative forcing, but aerosol, sulfate aerosol, volcanic ashes injected atmosphere, and also cloud feedback all are negative radiative forcing. So make sure that you have understanding on that. So as I speak, that aerosol injection into the lower atmosphere actually reflects sunlight, and it also work as a condensation nuclei, and it's create brightening of the cloud, more reflectivity, increase more reflectivity, and it actually reduce the precipitation. And those aerosol sources are this ocean, fossil fuel, and it's actually increased in the pre-industrial era. As I mentioned you, the radiative forcing. So carbon dioxide, methane, all are positive radiative forcing. On the other hand, aerosol cloud and aerosol soot, dust, all are negative radiative forcing. So what is the negative radiative forcing and positive radiative forcing mean? So you need to know that positive radiative forcing means Earth receive more incoming energy from sunlight than it's radiate to the space. Negative is the vice versa. So please review that Paleocene Eocene thermal maximum, and on that time in PETM time, the carbon dioxide concentration or greenhouse concentration was much more than today's concentration, and that's one of the reasons that tells us the climate all the way to the past, Paleocene Eocene thermal time. So those are the proxies that we know about the distance past climate. There are several questions about the climate proxies. So one of the climate proxies is fossil pollen on the plant, that we can get it from the sediment. And then we have oxygen isotope ratio changes, how heavy oxygen, and the higher ratio tells us colder climate, and lower ratio tells us warmer climate in terms of the concentration of oxygen isotope into the ocean. And then you have the coarse sediment sample analysis. That's by how we know about the past climate. So calcium carbonate shell organism found thousands of meters deep, which can only survive near the surface. Through that process, we know about the past climate. Temperature trend found what was the temperature at that time, and then vertical ice core extraction, that in the Antarctic the continent we have that. So that vertical core analysis actually telling us a long-term climate situation, and also the greenhouse gas tapped into the bubble, and from the concentration that time we understand what types of climate situation was there at that moment. So this is vertical core extraction is one of the climate proxy. And then we have dendrochronology. That means tree rings tells us the climate proxy. So it's a regular climate or a sound precipitation. Yeah, the tree rings actually grows very faster. If there is a drought or climatic hazard, you will get some hiatus of the tree ring growth. So from that process we know about the climate. And from the previous chapter you need to know some of the basic things about the atmosphere: convergent, divergent, trough, and ridges, low pressure, high pressure system, and stable atmosphere, unstable atmosphere, environmental lapse rate. All these things you need to know. And a dry adiabatic lapse rate, environmental lapse rate, wet adiabatic lapse rate, how those are related to stable atmosphere and unstable atmosphere, that you have learned from the chapter 6. All these things will be effective. And there's other things that ocean current, how ocean current influence that energy transfer from tropic to the pole. And you need to know some of the basic things about the polar vortices, meridional and zonal wind, how meridional and zonal wind actually helps to understand some of the severe winter situation in the south. So in spring, if there's a weak polar vortex, then you have meridional jet flow that actually push down all the way to south. All these things you need to know. So lastly, before the comprehensive talking, that's a diplomatic effort for climate change. So we have IPCC, and we have UNFCCC and Kyoto Protocol, Paris Agreement. So you need to know a little bit about that. Which agreement United States signed, which agreement United States did not ratify, when it has been drawn, and then again join with this agreement or something. These kinds of things you need to know. So in a nutshell, about the comprehensive, you don't have to worry about anything, because many of the questions from the comprehensive you have already answered through the reading quizzes or in the exam. And if you have basic understanding about the atmosphere, about meteorology, for the comprehensive part, you will do very good job. So I would say just review the chapter 16 to chapter 20, and climate classification and all these things that I told you. You will do a very good job. So I appreciate your participation in this course, and I wish you good luck. Thank you.